So this is where we change from solving or simplifying expressions into solving equations. Now, one-step equations, they're pretty small, okay? But the difference between an equation and an expression is an equation always has an equal sign. An expression does not. So an equation is usually made up of two separate expressions, which we will see. So before we look at examples, what is the solution specifically to an equation? Well, a solution to an equation is just a value for a letter or the letter in the equation that makes it true. So when it says something like solve for x or just solve, it really means what value of x makes the equation a true statement. Like if I were to compare values, if I said 5 equals 5, right? You guys would be like, hey, that is a true statement. It is correct. I know it's correct. Well, what if I changed it? What if I said that 5 equals 1 plus 4? Is that still true? Well, yes, of course it's still true. But as soon as I start changing it, let's say I made it 11 plus 4, well, now it's not true. Okay? So values need to make equations actually equal each other. So when I said 5 equals 5, let me erase that. Oh, it's the wrong one. 5 equals 5, right? That is actually a true statement. So whatever we get for these equations, the one side of the equal sign needs to equal the other side of the equal sign. So what is the solution to this following equation? X equals 10. So in other words, what value of x would make this true? Well, 10 would. I would say x equals 10 would make this true. That is a true statement. That would be my answer. Now that may seem a little direct right now, okay? But if we change it up just a little bit, let's say that x plus 2 equals 10. Well, now what value of x would make this true? Well, we would say, again, this would say what plus 2 is 10. Well, I know 8 plus 2 is 10. So if I said that x equals 8, that would make this statement true because 8 plus 2 is 10, and 10 equals 10 is true. So x equals 8 would make that true. Well, let's change this up a little bit more, okay? So we just saw addition. Let's do this with subtraction, right? What minus 3 would equal 10? Well, if x were 13, then x minus 3 equals 10 would be a true statement because 13 minus 3 is 10, and 10 does actually equal 10. So this would be the solution for x to make that equation true. Well, now multiplication, right? So 2 times what would equal 10? It's a pretty basic problem, but I know if I replaced x with 5, then it would be a true statement. 2 times 5 is 10, and 10 equals 10 is a true statement. So that would be my solution. So now division, right? Something divided by 4 equals 10. So what value divided by 4 would equal 10? Well, if I made x equal 40, that would make it true. Because 40 divided by 4 is 10. And again, 10 equals 10 is a true statement. So x equals 40 would make that true. So those last 4 examples leads us to what we call the principles of equality. And again, it's just manipulating the equations to be what we want, which is usually x equals some number. So see how these manipulate stuff, right? Instead of showing it, if a equals b, then if I were to add the same thing to both sides of the equal sign, then it doesn't change the equality of it. So just as an example on this one, let's say that I said 6 equals 6, right? That's a true statement. But if I were to add the same thing to 6, like, let's say 1, 6 plus 1, does that equal 6 plus 1? Yeah, of course it does. So if we add the same thing to both quantities that are equal to two quantities that are equal, it doesn't change the fact that they are equal. And it works for subtraction as well. So if you had two values that were equal and then you suddenly subtracted the same number from both, it's still going to be equal. But it works for multiplication and division as well. If two values are equal and then you multiplied them by the same value, still equal. If two values are equal and then suddenly you divided the same, both values by the same value, it's still equal. Now for one-step equations, you only need one of these principles of equality to solve any one equation. Again, this is very unique because they're only one-step equations though. So this one's a little different. I'm going to show the work on this using the principles of equality, but take 30 seconds and see if you can find the value of v that would make this a true statement. All right, 30 seconds, go. So one-step equations, we should be able to solve this in one step or with one principle of equality. Now this is showing two equal values. 18 is equal to this. Now on the expression on the right we have two terms, but it doesn't matter. We just know that it equals 18. So when I go into this problem and I say I'm going to operate on it with principles of equality, if I do something to one side and I do it to the other side of the equal sign, it's going to maintain the equalness of these two expressions. And 18 by itself is also an expression. So what I would really like to see from this is just v equals. So I don't really like that 20 is there with it. So how can I make that 20 go away is really a good question to ask in this case. And not everyone has to do it, of course. Some of you guys just did it. But again, I'm looking for principles of equality. How do I get rid of that 20? Well, I can get rid of it by making it a 0. How do I make a 20 a 0? Or what do I do to 20 to make it a 0? Well, just subtract 20. But again, if I put that line through the equal sign here to show if I do it to one side of that equal sign of that line, I have to do it to the other side as well. So I need to show minus 20 there. Now 20 minus 20, this is going to zero out, right? See how I subtracted 20 from both sides? So I'm using the subtraction principle of equality to make that a 0. And all I'm left with is this v. Well, what does v equal? 18 minus 20 is -2. So this is my final answer right here. Now, before I continue, this is good. Like, we used the principle of equality. We did it right. We subtracted the same thing from both sides of the equal sign. But if you were to stop here, I would warn you, well, maybe just like gambling, okay? Some people are like, dude, I really like to gamble even when I'm in math class. We don't recommend it because the odds right now are not in our favor because we're not used to this right now, okay? But if we can change the odds so that in our favor, then we're in much better shape, right? So here's what I would recommend doing is going back to the original equation. 18 equals 20 plus v, right? But now right here we just found a value of v that we think, some of you guys know, but we think right now that it is the solution to this equation. Well, if I wanted to know, I would just go to the v and I would replace it with that -2 that I just found. Now on this part, since it's not required, like there's not a part on the test that says check your answer to make sure. But checking your answers is always a very good practice for you guys because it's a sign of a very good problem solver, and people pay problem solvers a lot of money. So just check it. I would just use the calculator. I would do 20 plus -2. Does it give me 18? Bam, it does. And does 18 equal 18? Yeah, it does. That's a true statement. Since it's true, I know for sure that the answer I have here, -2 equals v, is the solution. So again, that may have been more work than some of you guys wanted to show. Again, this bottom part here, you're not required to show that work. It's always good to. But just checking your work, this is kind of a way on a test or a quiz to guarantee that your answers are correct, as long as you're typing this stuff into the calculator correctly. So we need to solve this problem as well. Same idea, okay? But right here, I've got negative 27 equals b minus 40. Now that I would first look to combining the like terms, maybe even distribute, which we'll get into, but I don't like that negative 40 term. And yes, this term right here, this is a negative 40. I don't like it there with the b. I just want the b all by itself, right? Like I want my final answer to look like b equals something. Because then that will tell me what value to replace b with, just like we did in 2.1. Well, how do I get rid of that negative 40? It's to make it a 0, all right? If I can make it a 0, then I would have solved for b. So how do I make it a 0? Just add 40 to it. But again, by showing adding 40 to the right side with b minus 40, I also have to add it to the negative 27 to maintain equality. So, yeah, negative 40 plus 40, there's my 0. And since it was, would have been addition, that's a phantom 0 there. And negative 27 plus 40, that's going to give me a positive 13. Now, just to check the answer on this one, again, we'll go back. Negative 27 equals b minus 40. Well, this should replace b with that 13 positive right there. Yeah, 13 minus 40, bam, it does equal negative 27. Again, you just put that in the calculator. Negative 27 does equal 27, that's true. So now I should feel a lot more comfortable about boxing in my answer or typing it into the homework. So for a problem like this one, negative 6x equals 36. Well, you could say, look, in those last two examples, we tried to make 0, okay? But we don't always want to make 0, right? Really what we want this to look like is just x equals something. Well, if I were to look at that red x, what is the coefficient of that red x? It's a phantom 1, right? We're just not showing it. But I do want a 1 as the coefficient of x. So the real question is, right now I got negative 6 times x. What I really want is 1 times x. So how do I change negative 6 into a 1? Okay, remember, one of the main skills we learn in this class is manipulating things to be what we want. How do I make a negative 6 a 1? Divide it by itself. But remember, since this is an equation, if I do it to one side, I got to do it to the other side as well. So see, negative 6 divided by negative 6, that is 1, which is right here. Not that we have to show it, but you can. And then 36 divided by negative 6, there's only one negative, so we know the answer is a negative. And 36 divided by 6 is 6. So just checking real quick, does negative 6 times x, or negative 6, equal 36? Question mark? And the answer is yes, negative 6 times negative 6 actually is 36. That's true. So now I could box that in and feel good about it. Now, again, some of you guys are like, well, I don't want to show that phantom 1 that you're showing. All right, don't show it. You guys don't have to. But if you want to, that's fine. I really do like to see the 1 there, just because it is part of the problem. We're trying to make that 1x, which will be very crucial, especially not only for these types of problems, but when we look at two-step equations as well. So this is w divided by negative 9 equals negative 4. Well, this is this one's a little different, right? It looks different. It probably even feels a little different. But how do I make that negative 9? Because right now it's kind of part of the coefficient of w, now that we're worried about that. How do I make that negative 9 a 1, right? Because I really just want w. I don't want w divided by negative 9, which really means I want 1 there. Well, w divided by negative 9, if I wanted a 1 there, I would simply multiply that by negative 9. Now, without going to fraction multiplication, it's really negative 9 over 1. But what this does is it makes that a 1. And I didn't just cross those out. That's really a slanted 1. Just remember, if you do it to one side, you got to do the other side as well. So 1w now, because negative 9 divided by negative 9 is 1, is going to equal negative 4 times negative 9. There's two negatives being multiplied. 2 is even, so the answer is positive. 4 times 9 is 36. So let's just go back and check, right? We got 36 divided by negative 9. Does that equal negative 4? And yes, it does. 36 divided by negative 9 would make that a negative 4. That's true. Negative 4 does equal negative 4. So that completes that one. Again, you don't have to show the 1 there. But if you want to, that's fine too. Let's address that inverse operation stuff. So when we look at problems when we solve equations, really what we're either trying to do, and this may seem like a long explanation, but it's part of the presentation anyways. There's two values we're trying to make when we solve equations. Two values. And this, of course, is outside of distribution and combining like terms, which we will see. You either want to make one of these two values each time. You either want to make 0 or you want to make 1, which we've shown, right? Either you make a value 0 or you make it a 1. In this case, we made it a 1, right? Well, for this specific problem, how do you make a 1? Well, right there it used to be w divided by negative 9. Well, this is where inverse operations come in handy. So see how it's w divided by 9? Well, how do you undo division? You undo division with its inverse operation, which is multiplication. So what I did is I multiplied it by 9. And since I multiplied, negative 9. Since I multiplied it, I divided something that I multiplied by itself. It makes that a phantom 1 right there. So w divided by negative 9. When I multiply it by negative 9, right? And this is going to fraction multiplication, which we haven't gotten into, but I'm going to show it anyways because hopefully it will help. I have negative 9 over 1, which I'm multiplying it by. Well, this multiplied together, I'll give myself more space here, would be the same as negative 9 w, that's the numerators multiplied together, and the denominators multiplied together is also negative 9. Well, what do we see here? Well, let me use a different color. What do we see here with this negative 9 and negative 9? It's being divided, right? And anything divided by itself makes that a 1. Now, we still got that w. And that's why that becomes a 1w. So, to emphasize this, we're making zeros or ones. I'll just finish this thought. Is when you're making 0, you'll either do it with addition or subtraction, the principles of equality, right? And when you're making 1, you're either going to be using, just like we saw in this example, either multiplication or division. So this one, it was divide by negative 9. We made a 1 by multiplying it by itself, right? Negative 9. Or you could, you can consider the fraction multiplication bit right there. Already, remember, equations just have an equal sign with expressions on both sides of the equal sign as well.